Before I start today's lesson, I just want to go back to the worksheet you were completing yesterday because you need to understand how the first row of questions, since x squared was equal to a perfect square, it resulted in a rational answer that had no square root in it. So you were able to take the square root of 100, take the square root of 4, and take the square root of 1/9, which gave you positive or negative, and then an integer number. The second row of problems, x squared was equal to a number that was not a perfect square. So when you took the square root, it had to stay under the square root symbol. These are your irrational numbers, like positive negative square root of 5, positive negative square root of 17, and positive negative square root of 13. So I made corrections on some of your worksheets if you didn't express it correctly. Now today there's going to be an extra step. So I'm going to go into today's lesson. How do we solve equations by square roots? That's what we did yesterday, and write our answers in simplest radical form. So today we're going to talk about simplest radical form, which is going to be extremely important for the rest of this topic. It's going to be important in next year's course, whether you're in geometry or whatever, and algebra 2 and forever on. So this is going to be very important. Sometimes we could be asked to solve equations and express our answers in simplest radical form. This means that there's no more perfect squares in the radical. So we break down the radical using two factors of the radicand. The radicand is the number under the radical. Where one factor is a perfect square, it is extremely helpful to use the largest perfect square that goes into the radicand. So here for 24, I need to break that down into two separate radicals. The first one's going to be a perfect square, the other one's going to be the other factor. So some of you may be able to just think, okay, what perfect square goes into 24? Let's say you can't. Just like with factoring, if I put 24 divided by x into the calculator and look at the table of values, let's go from 0 to 24, look for perfect square factors. So I see 1 times 24, and neither's a perfect square. Well, 1's a perfect square, but I wouldn't use that actually to break it down. 2 times 12, 2 isn't a perfect square, 12 isn't. 3 times 8, neither a perfect square. 4 times 6. 4 is a perfect square, so that's going to be the factor I use to break down the square root of 24. And then the first radical, since it's a perfect square, you can get the square root of 4, which is 2, and then I bring down the square root of 6. Okay, 32 has a little bit of a challenge in it. Okay, now I'll do 32 on top instead and go to the table of values. And if I go from the top, 1 times 32, 1 is a perfect square again, but I wouldn't use that. 2 times 16. Do we recognize 16 as a perfect square? So 16 is going to go in the first radical and 2 is going to go into the next. Now, if you didn't take that biggest perfect square, 16, and you looked at the next pair of factors in the table of values in the calculator right here, 4 times 8, 4 is a perfect square, but it's not the biggest perfect square, so you wouldn't want to use it. So that's why it's good to look at the list of factors and make sure that you're taking the biggest perfect square. Now, square root of 16 could be simplified to 4, and the square root of 2 comes down. So these answers have now been put in simplest radical form. So now for the next row, we have to do exactly what we did in that last row of problems yesterday. Solving for x, you want to take the square root of each side. So the left-hand side, the square root of x squared is x. On the right-hand side, you can't get the square root of 12. You're always going to get a positive negative when you're taking the square root, but since you can't get the square root of 12, we're going to leave 12 under a square root. But you see how it says simplest radical form? Square root of 12 could be simplified because a perfect square goes into 12. So I'm going to bring down the positive negative, Instead of the square root of 12, I'm going to bring down 2 square roots. Now, 12, many of you could probably just picture what the factors are. Let's say you couldn't. Let's do 12 divided by x. Look at your table of values. I'll go from 0 to 20. Okay. Going from the top, 1 times 12, neither is a perfect square. 2 times 6, neither is a perfect square. 3 times 4, 4 is a perfect square, so we'll do 4 times 3. Then I'm going to simplify this first radical. So the positive negative comes down, and we get 2 square root of 3. And that's your final answer. Next one, same thing. Square root of both sides. The square root of x squared is x. Square root of the number, I'm always going to put a positive negative. I can't get the square root of 28. It's not a perfect square. So I'm going to write it down under the square root. Then I'm going to bring down the positive negative and 2 separate radicals. You could put 28 divided by x in the calculator, or realize 4 times 7 is 28, and 4 is a perfect square again. So we bring down the plus or minus. The square root of 4 is 2, radical 7. Final answer is positive or negative 2 radical 7. The next two have an extra step on top of that. It says, if necessary, isolate the squared term first. So in number 5, the x squared isn't by itself because of that 2 in front. How am I going to get rid of this 2 in front of the x squared? I have to divide both sides by 2 first. That gives me x squared equals 18. Now, once the square term is by itself, I could square root each side, get x equals the positive negative square root of 18. And again, there's a perfect square that goes into 18. Either you know it and you could break it down right away, or in the calculator, I'll make that 12 into an 18. Press enter, table of values, scroll down, 1 times 18, 2 times 9. 9 is a perfect square. I bring down positive, negative. Square root of 9 is 3, and bring down the square root of 2. Again, putting a radical in simplest radical form is going to be following through the whole topic. So if you're struggling and not understanding, please reach out and talk to me tomorrow before we move on. Number 6, the x squared isn't by itself. How are we going to get the x squared by itself? Subtract 5 on both sides. When I subtract 5 on both sides, I get x squared equals 40. Now, to get the x by itself, I take the square root of both sides. The square root of x squared is x equals positive, negative. Can't get the square root of 40, so I leave it under the radical. Find a perfect square that goes in, so I'm going to put a 40 on top. 40 divided by the x. Look at the table of values, scroll down, and where do you see a perfect square? 4 times 10 right there. So I'm going to bring down x equals positive, negative, 4 times 10. So x equals positive, negative 2 square root of 10. And this is your final answer.